As previously mentioned so far in this program, the discrete input connects to input devices that exhibit an on or off, open or closed signal equivalent to a switch closure. Some discrete input field devices may be selector switches, push buttons, photoelectric eyes, limit switches, circuit breakers, proximity switches, motor starter contacts, level switches, thumb wheel switches, and many, many more. The input signal to the input interface looks the same regardless of where it comes from. That is, the field device that originates it. The only thing the interface cares about to properly recognize the on or off status of the signal generated by a field input is the voltage, amplitude, or magnitude and the type of signal. For instance, 120 volts AC or 120 volts DC. For this reason, PLC manufacturers make input interfaces available at various AC and DC voltage ratings. Typical ratings for most basic standard input interfaces are 24 volts AC or DC, 48 volts AC or DC, 120 volts and 230 volts AC or DC, TTL inputs, which stands for transistor logic, for communicating with low-level electronic signals. Other types also include what's known as isolated inputs and the non-voltage input type of interface. All input interfaces receive the necessary voltage and current for proper operation from the back plane of the rack or enclosure where they're inserted. During operation, the CPU will go to each input module and examine the status of the signal. The signal read by the CPU is a result of a single conversion from the original signal, for example, from a 120 volt AC signal from a limit switch. This signal conversion takes place because the processor cannot really read directly the 120 volts AC. Instead, through the input module circuitry, the signal is converted to a level which can be read by the CPU. This level is, in general, a logic level signal ranging between 5 and 10 volts DC. The field status information of on or off, open or closed, provided by the standard input module to the processor, regardless of signal level or rating, is placed into a 1 or 0 in the input table every time the processor reads the input. Each input address has an input table location where it's mapped. These locations are examined during the execution of the program or during the program scan to determine whether or not a PLC instruction would be providing power continuity or not in the control ladder program. The instructions that examine discrete inputs include the normally open and normally closed symbolic instructions. Modules that receive multiple inputs or multi-bits, such as thumb wheel switches, use the so-called register or BCD interfaces. These register interfaces get their input value into the word or register storage area using other types of symbolic instruction called block transfer or get data. We're going to thoroughly cover these instructions, their uses, and programming later during the training course. Now, to properly apply all these input interfaces, it's important to have a general understanding of how they operate internally and to have an awareness of certain operating specifications,